Okay, sorry for the slightly delayed start. Thank you all for coming. Sorry I scheduled this meetup on a Friday, on a Thursday before a bank holiday Friday. I forgot is the honest answer. But yeah, thank you and welcome to the April meetup. As always, we're a meetup that happens every third Thursday. So yeah, come along and tell your friends and all that sort of stuff. If you'd like to speak as well, submit a talk issue and we'd love to have you come down. The guest password has changed as well, so take note of that if you want the Wi-Fi. Obviously, as always, again, we've got food coming at 7:30. There'll be crap tons because I've ordered the usual amount and there's not the usual amount of people. So feel free to take as much home as you so wish and fill your boots. We're also now sponsored by the lovely Harvey and Ash, those two guys there.
Hey guys.
Woo.
Thank you.
So they are our exclusive recruitment partner for the next 6 months now. So yeah, give them a look if you need jobs, all that kind of thing. Also, Cloud Call, we're in Cloud Call office, as you know, as well. And me and Linda both work for Cloud Call. We're the two Cloud Call people here. So yeah, there you are. Right, so next time as well, we've got a really exciting talk. It's not the 18th of April because today's the 18th of April, but it will be in May, and we've got a really good talk on D3JS, which is like a data visualization thing. So that'll be a really exciting talk, and that's by someone from Compare the Market again. Also, we've had a bit of a rebrand as well. I'm wearing a T-shirt with our new logo on it and everything, which is paid for by Harvey and Ash. We've got T-shirts down here, and we've also got stickers at the front. You can help yourself with stickers. T-shirts wise, I can kind of give them out, but there'll be a giveaway for best photo and best like photo caption. So if you just do a tweet with a photo during the meetup today, I'll give you a T-shirt. And that's it. So now over to Girish on GraphQL. Take it away.
Right, good evening everyone. I'm a first time, this is my first presentation as well, so go easy on me, especially with the questions. So, let's start with the first one. So, GraphQL and introduction. So, on the agenda for today, we're going to be talking, going briefly over what GraphQL is, the components that make up the GraphQL API, GraphQL server and client libraries. Going to do a simple demonstration of a simple Node.js GraphQL server, some GraphQL pros and cons, and questions at the end. Yeah, I was working on this. I mean, I was just saying, Josh, I was spent the last sort of like an hour doing trying to work on this, so it might have some what issues with it, but you have to bear with me. So what is GraphQL? So it's a specification developed by Facebook and open source in 2015. It's a query language for your API and server-side runtime for executing API calls. It isn't tied to any specific database or storage engine. It can provide a more efficient and powerful, flexible alternative to REST. Apart from Facebook, users of GraphQL include GitHub, Shopify, Twitter, Coursera, Yelp, WordPress, and Pinterest. Out of interest, who's used GraphQL, and have you used it in production, or have you just sort of played around with it?
In personal project. Right now, one personal project is based on GraphQL.
Okay.
I use it for my Gatsby blog.
Gatsby stuff, and also actually push types for little things.
Okay, so let's get started. So, GraphQL, graph query language. What does the when I first came across it, I wondered, what does the graph part of GraphQL refer to? So what I found that it actually refers to application data graphs. So a lot of modern applications can be represented using a graph of nodes and edges. And here's an extract of data from a book application. So you can see here the nodes represent the objects, and the edges represent the relationships between these objects. So if you look at a simple GraphQL query, and we'll be going into the syntax of GraphQL query a bit later on, but that query might return a JSON something like this, and the representation of the extracted data is shown here. So GraphQL API components. So there are three main building blocks: queries, schema, and resolvers. So let's talk about each one. So queries, so they're sent from the client to the server. So this is the operation type. So the operation type can either be a query, a mutation, or a subscription.
Getting angry at us.
This part is a query to run on the GraphQL server. If it's not all that clear at the moment, hopefully it will be later on, because I'll be putting all the components together and see how they all work together. So hopefully it'll be a bit clearer then. Then we've got the operation name. So that bit is optional, but for debugging and server-side logging reasons, it's useful to give your queries meaningful names. Got the variable definitions. That's where you declare the types of variables you are planning to provide. And then we've got the fields. So that's the fields, that's what data we want returned from the query. So the schema. So it's a single source of truth in the GraphQL applications. Can be seen as a contract between the server and the client. Defines the data available from the API and how clients can request it. Used to validate GraphQL queries. Strongly typed and most commonly defined using the GraphQL schema definition language. So if you look at a simple schema, and there's the data that it's representing. So there's a data set. So if you look at type course, that's an object type. It defines the structure of the course's data model. Then type query. There. So that's a root type. It's equivalent to get in REST. Defines queries which are of operation type query. And other root types are type mutation, which is equivalent to post, update, and delete in REST, and type subscription, which provides real-time updates, and that's currently experimental. So resolvers. So provide the instructions for mapping a GraphQL operation defined in the schema to an action, which is usually a function. So you can see here the course in type query is in the root resolver. It's saying to map the course query to this get course function. And also as well the courses one underneath that, which is this bit here. It's getting mapped to the get courses function. So if you put it all together, so the client sends a query to the server, and we then have validation against the schema. So there's a check done, and checks that a course is defined in the schema, and variable type is of expected type. So the server is expecting, well, course is defined in the schema, and also is expecting int as a variable. It also checks that the data that the query is asking for is in the type course. So there, so we can see that titles there, authors there, description, topic, and URL. If you were to put something that wasn't in the type course, then it would throw an error. Then it goes to the resolver, and that decides what function to execute. So here, course is saying, the query of course should get mapped to get course. So the get course gets executed, and it returns the data back to the client.
Demo time.
Right,
Good luck.
thank you.
Demo fail.
Yeah.
Right, so if we first look at the code, so this is getting the Express module. This is the Express GraphQL is the middleware, and it's also using GraphQL as well. And there's the data that it's using. It's just a simple, it's just like a simple file. It's in a file, JS file. And one cool thing about GraphQL is it comes with a graphical interactive in-browser GraphQL IDE, which allows us to test queries. So we're going to set that to true. In production, you wouldn't set it to true; you'd set it to false. But let's have a look. So I've got it running at the moment, but if you do node server.js. Refresh that. So here we're sending a query to our GraphQL server, and we're saying to get we're saying the course ID is 1. So we run that. So what we get if we change that to 2, then we get a different set of data returning. Cool thing about this is that we can specify what we want. So if you want to just say our API, just say we don't want to get the author from the API, we can just remove that, run it, and the data that we get back has excluded the author. You can also do get all courses, and so if we say the topic is Node.js, that will get all the things from the data file that's got that has the topic as Node.js. We can get them all by getting rid of that, and that will return all of them. So that live demonstration, the GraphQL server was built in a Node.js environment using GraphQL, which is the GraphQL.js, which is the original reference implementation of the GraphQL specification, Express Web Server, and Express GraphQL, which is the middleware between GraphQL and Express. So if you want the source code, it's available on my GitHub page. That URL. So server libraries, there are server libraries available for other platforms. So many other programming languages support GraphQL. These include C#, .NET, Clojure, Alexia, Erlang, Go, Groovy, Java, PHP, Python, Scala, and Ruby. A full list is available on the GraphQL official site at that URL. So Java client libraries. So it's used to interact with the GraphQL API from the client side. Two of the most popular are Apollo Client, which is a powerful JavaScript GraphQL client designed to work well with React Native, native, Angular, or just plain JavaScript. And the Relay, which is Facebook's framework for building React applications that talk to a GraphQL backend. There are client libraries for other platforms as well. Again, there is support for other programming languages. These include those shown in the list there, and the full list is available at that URL from the official GraphQL site. So if you look at some of the GraphQL pros, so imagine that we have to build something like this, which displays user's name, shows the post he or she has created, and shows the followers the user has. So with if we build it with REST, we might have the following endpoints. So we might have an endpoint user/ID to fetch the user, might have that endpoint to fetch the post of that particular user, and then we might have that URL to fetch the followers of that particular user. So with REST we have to make requests to 3 different endpoints. So first one to fetch the user data, second one to fetch the posts, and the third one to fetch the followers. You're also overfetching since the endpoints return additional information that is not needed. So for example, in the first one, when we fetch the user data, we only want the user's name, but we're getting a whole load of other data associated with the user. So the blogging app built with GraphQL, it only has one endpoint, and so a query might look like that at the top there, and the GraphQL API will return all the will return the data in the format shown here. So as I mentioned earlier, so the client can specify exactly what data it needs in the query, and also notice that the query has the same structure as this server response. So this reduces network requests by allowing the retrieval of all data in a single query. The clients can specify exactly what data is required, so there's no overfetching, and basically it shifts this multi-request complexity to the server side. Another cool feature of GraphQL is schema stitching. So schema stitching allows the creation of a single GraphQL schema from multiple underlying GraphQL APIs, sub-schemas. So these sub-schemas can be either local to the server or running on a remote server. It's useful with microservices architecture. So each microservice can have its own GraphQL endpoint, which can be consolidated to create one GraphQL API gateway. So another advantage is there's no need for versioning. You can easily add new fields and types to our GraphQL API without impacting existing queries. No need to create a custom data endpoint, so because the exact data requirements are specified on the client side. The GraphQL server will only return data requested by the client. It's strongly typed, which, being strongly typed, should make GraphQL less error prone, and also allows it to be validated during compile time. So introspection. So GraphQL has a built-in introspection system that publishes the schema structure. This provides information about what queries are supported and what data is available. Makes it easier to auto-generate API documentation. So let's look at some GraphQL cons. So denial of service attacks. So GraphQL can be attacked with overly complex queries that can consume all the resources of a server. Although it's not specific to GraphQL, we have to be extra careful and have to put in place mitigation functionality, such as query validation, query timeout, limiting the maximum depths of the incoming queries, and limiting the amount of objects that can be returned. Because GraphQL requests are most commonly implemented using HTTP post, you need to set up your own caching support, as you cannot use the native HTTP caching mechanisms. The request cannot be bookmarked. Requests do not stay in the browser history. You can require that the clients use GET for all requests, but it's not ideal because mutations will get cached too. Should you consider using GraphQL? Well, here's some scenarios where GraphQL could provide a good solution, which include the data from your API is changing frequently. GraphQL reduces the need for versioning, so it'll definitely be an advantage to use it if that's the case. If you're building a rich UI, UX-based mobile applications, if these applications are used over slow networks, GraphQL helps you load only what you need and with fewer network requests, as you saw earlier. If your application has multiple schemas from multiple sources, you have many clients with different requirements from your API. GraphQL reduces the need for multiple custom endpoints, which we talked about earlier as well. And if you're working with microservices architecture. Okay, thank you for listening. And do we have any questions?
Okay, I'll go with one.
Okay.
Have you ever used GraphQL with TypeScript?
Oh no, I haven't. No.
Okay.
I mean, yeah.
Okay, I will direct the question to public. Have you ever used any GraphQL with TypeScript?
I have a bit, yes.
Okay, super cool. What is your experience with this one, and how do you manage these things to basically to specify your schema just in one place and utilize that inside your TypeScript types and inside your GraphQL schema?
Yeah,
it is possible, and there is loads of ways of doing that, but it's tricky.
Yeah,
Right in generator.
I didn't bother to go that far with it. I just copy pasted, if I'm honest. Yeah.
Because I've got the second version of this question. Have you ever used GraphQL with TypeScript with Mongoose, for example? That gives you additional layer of types on top of it.
Yeah.
So you can specify your types, your schema inside like 3 different objects.
Is there not some library or something that consolidates?
There's loads of it. Yeah, there is like a ton of libraries that can help you with this one, but
any good
none of
ones?
them is working for me.
So the way I approached this same problem in the past is to write my own data definition, so define the data in one place, and then actually generated the other schemas from that. So basically write a simple schema generator that basically generates schemas for the other.
Not bad, yeah.
And you have like the single source of truth, which is the
Exactly. That's the thing that I want to achieve.
But I think all these things are subsets of each other, so there's no superset. So basically, I think you're very.
I try to stick to the source of truth that is coming from my TypeScript definitions, because TypeScript helps me the most from out of this whole 3 schemas that I define. So I'm doing everything to force everything. Right, GraphQL, listen to TypeScript, because TypeScript knows the best. Yo, Mongoose, listen to TypeScript, but in practice it's not as easy.
Well, presumably you can run across your TypeScript to determine what the type of things that you're using as data types somehow, and then actually run across those and actually introspect TypeScript.
Yeah. There's not a good solution basically so far. I'm sure there will be.
Yeah, because it's a quite popular stack. Yeah, GraphQL is a big hype.
Mm-hmm.
It is like
TypeScript, come on, it's amazing.
It's the biggest hype.
Yeah.
I have a quick question. Can I ask a question?
Yeah.
So what I found, I've done a few little things, prototypes and things like that, where I've not been particularly mindful about efficiency at all. And I think when I've created my providers, my resolvers, functions and things like that, I've actually just provided all the information it could ask for, and then like you leaned on the query, the GraphQL query language.
Yeah.
It's very inefficient to do that, because basically how deep you go with the query, I don't know how it actually all hooks together, but basically my each layer of my provider has actually done all the work required to produce all the possible things it could do. So basically, as you talked about, you're over accessing information. So I'm actually over accessing information from my database, and the actual query could be like very simple and just like one little bit of that. And so I've actually fetched all this data, and then my actual resolve graph query query part of it has just said, oh, and I just want this bit, and like all that stuff was wasted work. And obviously you can write different functions, little provider functions, whatever it is. But then you start ending up in the same problem you had with REST, where you could actually written a custom interface if you wanted to for that particular query you wanted.
Yeah.
And it's basically, I just think, I don't know, I've not really gone really into this, but my theory is the fact I'm just pushing the problem down further into the stack.
Yeah.
So it's the same problem, I'm just pushing it down into the stack. And presumably you could be very clever, whereas obviously you can actually introspect the actual GraphQL that was provided, and then you only say, well, okay, then I'm now going to write some very complicated code that basically interrogates the query, and then actually then determines how that. What I was wondering was there anything you come across where it actually then translates that into a SQL call I can make, or a Mongo query that I can use to actually, it knows what it is I want out of this. So basically something, that's my fear, is the fact I'm actually overfetching stuff.
Yeah, I mean, with regards to like sort of getting stuff from Mongo databases, that's all done on the server side.
Yeah, so like, what data I want is basically the thing which is determined by my query.
Okay.
Yeah. So the projection and selection of information.
Yeah.
The reduction. Obviously, the whole point is to reduce that amount of data that I'm actually having to touch or access or read or whatever it is. And then, so that's really my fear with GraphQL.
Yeah, I mean, I suppose you could get it, but then, I mean, if you do it on sort of somewhere with like a good internet connection, and then you sort of overfetch, you won't be as bad. But if you sort of doing it on a mobile phone, mobile app, where there's a sort of, you might not have as good internet connection, it is definitely worth considering this, because then you don't need to, as you said, overfetch everything.
Yeah, you don't overfetch it over the comms line, but you still overfetch it from the database. Sorry, thank you.
Yeah, and then so you and then you just have to, so your code on the client side will have to sort of, if you do overfetch, sort of just pick out the bits that you need.
I'm talking about massive object databases, queries go over like complex things, so it's quite.
So do you actually use that app? So I take it this is not a sort of personal project. It's sort of you use it at your.
Yes, I have clients who are research clients.
Okay.
So.
Yeah, I mean, even though I've sort of done talking, I just cover the basics, and I've just done sort of simple stuff. I've not used it sort of in a big project or anything, but I would like to do that next. So, okay. Anyone else? Okay. Okay then. Thank you then.
Thank you.
Sorry if it was a bit rushed. It was, the first presentation, so
No, it was very good.
Very
yeah.
No, I definitely want to do like another one now. So, but hopefully the next one I do will be a bit better. So, presentation-wise, I think I rushed through that a bit. So.
Right. Here's a bit of feedback for you. Don't apologise.
Okay.
Don't apologise at the beginning and at the end. And, so just it was what it was. And that's what you.
Yeah, it was very good.
Yeah.
To be honest, I was, that person that did what's the person's name that did the embedded JS stuff?
Dave Irvine.
Yeah, I was sort of, don't know, for some reason I sort of fear with him, because he always asks like difficult questions, doesn't he? So like, I know.
Lucky he's not here today.
Yeah, no, it's bad. Like, when I didn't see him today, I sort of, and it sounds bad, you know. That was sort of,
It's a relief.
yeah,
There's always going to be a large percentage of the audience who know more about it than you.
yeah,
you
yeah.
you,
That's what,
you
yeah,
are, and basically you're just spreading it around with it. So it's basically, don't, you know, and just to say, is anyone who's got more experience?
Yeah, thank you for giving that talk. Please haven't decided to rear their ugly head yet, so yeah, talk amongst yourselves and we'll try and get that.
The slides also are a bit difficult to read.
yeah. I
So
mean,
that's just a sort of like feedback.
yeah,
No, it's just feedback. Obviously,
It's a very good feedback, and I always prefer to use like a light theme for my code editor.
Oh, okay,
I
yeah.
know, personally, I know probably in the room we've got like 90% of haters of white themes or light themes. Personally, I use a dark theme as well, but for presentation, actually, in this kind of lighting conditions, it works better. The light theme.
yeah. I mean, looks. I mean, on there it looks quite light on there.
Yeah, but have you ever heard feedback from the client that, oh, on my browser it's looking broken, and
Okay.
exactly the same thing. Yeah, for us it's looking it's not readable, but yeah, it's just feedback.
and the actual bit with the code was like a tiny area of the screen. So basically, you perhaps need to zoom that out when you're talking, and then you can zoom back in to actually. Because the fact that you actually had it labelled was quite nice. To actually, I labelled some of the component parts.
Yeah.
But basically, it was like even that bit of the labels was like very small.
Yeah, I was trying to fit too much. I think I was trying to fit too much in as well. And then those, you know, because I'd used a lot of animations in this as well. You know, when I said I was like doing it sort of last minute as well, I was hoping that they were in like the correct order and everything.
Just feedback. It's not criticism. It's just.
Yeah, no. It's that's really good.
No, very positive feedback. You did very good of you to stand up there and tell us.
Did you? I mean, is this the logo for the LeicesterJS? Did
Yes,
you say?
that's a new logo for LeicesterJS.
Is it? I mean, I thought
It's
Josh
not a
had
Firefox.
yeah, that's what I mean. I thought he had meant to a Firefox conference and he had the T-shirt and everything. But like it is a fox, isn't it? Though you look,
It is a fox, but not fire.
Leicester, of course, Leicester symbol is the fox. So.
Okay, yeah. Oh, okay, yeah. That's right. Yeah.
And if you look at the logo, can you show us the logo, like in front? The shape of it is L, like Leicester. Yeah, you get it? I didn't design it, but I didn't design it, but I heard that.
Like a J.
What is it?
Can I ask one more question about GraphQL?
Oh, I should have sat down. Yeah. Sorry. Yeah.
What was your use case to explore GraphQL? Was it only just hype on a Twitter?
Well, I mean, I've sort of, because I go on medium.com and I sort of read a lot on there, and then they had articles on there, and then I came across it, GraphQL, and then I thought it was something to do with sort of stats or something, you know, because of the graph part. So I didn't pay it much attention, and then now it's sort of getting more and more hype as well. Even if you do like a job search, you know, if you type in good GraphQL, you don't get much back.
Yeah.
But then I sort of started sort of noticing more and more. So I think it's obviously starting to pick up more and more now. So yeah, so I thought, okay, let me look into it. So
it's amazing in Gatsby. Obviously, just like GraphQL, every single thing you do, even if you open files on disk, is you use making GraphQL.
That's what I noticed. Like Gatsby is for loads of people, it's an entry point for GraphQL.
Yep.
Because you have no other choice. If you want to fetch something, you have to use GraphQL.
Yeah. But I think it's a few principles. It's just like if you understand how to use GraphQL, you can do it in anything to do with data querying. If you know how to write a resolver, because you might have to write. You might not be relevant. You might have to write
First one to that.
Yeah, no, go for it. Please help yourself. Please eat as much as you can.
did you design this yourself, or did you get someone to design it? Or?
No, because I'm a developer, not a designer. I got a designer to do it for me. Take one. Feel free to have a T-shirt as well. You get a T-shirt as well because you're special. From Take one. Don't get a woman's one though, because I've got women's.
I really want one few of these.
Matthew, remember, rule number one, meetups and conferences are all about the stickers.
People go to conferences and meetups just to grab stickers. Okay. Smash. Huh? Take one. Smash a photo and
I thought that's a magnetic dish.
Took a wide angle of it.
Thanks a lot for that, mate.
I mean, I don't think I think I rushed it too much, and
No, you did well, mate. Really well. Yeah, really well. Well done.
I think the next one will be. I think I'll be not as nervous for the next one, so I have to think of something to do.
Yeah, absolutely. Yeah, I'm sure you'll find something.
Oh, right, he's on the.
Yeah, they're not affiliated with Tarkor.
But,
They're a separate company.
yeah, because I played. Yeah, because I applied for those ones, and like I was going to go through one agency, but then the job got when it expired. But then when I looked at the hardcore site, they had two on there, so it's like a senior. Yeah, so it was like a
Okay.
senior. Senior developer front end.
Right,
Them
okay.
both got hired, I think. So.
We haven't hired anyone. So,
Oh, okay.
Yeah, I wouldn't worry too much.
Someone doing serverless stuff right now.
You're sorry?
So someone is doing serverless presently. Is that you?
Unfortunately, yeah.
Unfortunately, nice. I can't wait for it, man. Good luck.
So, yeah, thank you. Yeah, we'll see.
Can't
I'll try
wait.
and keep it short and sweet, but
Sure, just keep it good, man.
keep it good. Good advice there. But yeah, tell me about this type of conf anyway.
Man, it was amazing. Like loads
It
of
sounds
amazing.
sick. I'm kind of gutted I couldn't come.
Next time we'll sort it out. We organized this conference in Raffle because the whole conference was organized in less than 4 months.
Really?
Yeah, and we ended up with 300 people. So
Wow.
Conference just paid by itself. We
Yeah.
didn't earn any money, but it was good, man, because we met loads of really cool people. It was very good.
I'm gonna say
Where was where was the conference held?
The conference was in Porto, in Portugal.
Oh, okay.
Yeah. I'm gonna have a slice of pizza. If you don't mind.
Yeah, I hope so.
I don't know, me personally, folks that might be thinking of trying to, you've got an interest there and you're trying to do things So if I'm very very, very rarely. I do actually see who actually interview by contacting me and saying, well, I won't be pregnant one day. So next time I'm going to organize someone checks in, interested, I want to do a week. So basically, she got in there to do some work. I paid for him to do some work. Did it well. But I'm very optimistic. My stock materials are very useful, but they have some of the skills that I want. I learn the other parts of it, and that's really what I without any attitude or like not throwing up the house and saying I can't do this. So basically, the things that go through express I'm very magazines and fashion e-commerce stores. And right now he's with a contract of collaboration.
He just no, it's a worldwide qualification. So you
Why did you start GraphQL? GraphQL. Okay. That Jordan showed me the way how to use
I've been on a bit of a detox. Well, I say detox, I'm just going calculate. And today's my first day of pizza and eating things I need to.
they do like certifications, like and they do worldwide. Have you ever tested Leicester, for example? You go visit whatever they say Yes, that's right. Go by what course today you want to do. Study the book, then you book the exam and you just go into the exam.
The advice I give is the fact that the most important thing about any
So the
verb
mobile
in
phone,
my
you
view
pop up the card,
is being useful. Okay. So basically, if you illustrate what you know or what it is, it's about being useful, being willing to go and find out if you don't know, get on with it, crack on with it, try and work it out, whatever it is. That's like in your one. And having your own project leads you into that sort of like frame of mind because you're trying to solve your own problems. And so you actually learn, rather than just learning this theoretically, it just goes in and out. Whereas when it goes in and then gets expressed in the project, you know
Yeah.
that you can do that so-and-so, that's in so-and-so, so-and-so. So somebody has a particular thing in it here. In your own project, you know where that particular piece of code is. So you actually go and quiz it in the project. Also, it opens the
Go powers every time you Google. So when you Google something like, I don't know, LeicesterJS, probably it's going to be LeicesterJS.
building with science, then
Ukulele is like when you know before you do that when you start doing ukulele games.
I actually didn't do it because purely because we were in real time, we were working in real time.
Sort of knows
Or
your
like I play with kids and so basically we're writing games, so
she's one singing track and
very simple things like motion,
so you know so
it's one of the universities
so normally it's like you go to like
exams
very
in Leicester or something like
but like
useful.
probably she's
You actually go and do a course on like the front end around the project and actually just
she actually
what's this guy called Max
she's
several courses
and also
including like Microsoft Sentences and perhaps 5 you can actually build a project, I say in a school project, how can I make this project live, which I have for to create a business around or either solve a problem I have in the past, like so you buy constantly is a similar instance where you think that was if you could like if you have some automation tools, it would actually be an advantage for you. You can start building and people love I know I do I love people solving their problems because basically thesis to me so what have you done about it? And well, unless you've actually addressed it yourself, and I'm not addressing it because it's not very high on the list of things to do. Well, I'd love to get people come along and say, I mean, first thing is, tried this, you've done that, I've done this, it's not working, so, I can probably then help you, I can actually, work with some technology that actually solve your problem. I know you've got an acute problem, if you try to solve it, if you say, honestly, something yourself and they say, yeah, I'm not going to it. And it comes to being these are just bullshit excuses for it's not really a problem that's so complicated you like anything to console is the way of doing debugging. Oh, okay, so I'm using semicolon, I'm using semicolon, or I'm indenting in a particular way, or whatever it is, that's what linting is for. It does create some syntax errors. Basically, it's about controlling your syntax. Is what the code pool is telling you. Yeah. Without actually a project or directory or only bullet as a character like it is, then perfect. JS and suggesting plugins you might
He's not in the company yet, but he's a lot of YouTube videos.
Like 20 years ago. I feel like really by now.
Exactly. That's like I'm cool dad. I'm really old dad. I'm really cool dad because basically I teach all their friends. So like when I go to school, hey Paul.
What kind of stuff do they make?
Oh really? Yeah. Man, we need to master this SEO game.
Yeah, you'll be pleased to know that my SEO budget for this meetup is 0. That's right. Approximately 0. Righty.
Who are these guys? What's the event? Are they developers or? No man. How big they are? Oh really? Okay. Okay, I see. That's nice. That's still really cool. That'd be very cool.
Hey guys, feel free to put food in with you if you want.
Yeah, very tiring, isn't it?
Yeah.
It's hard because it's hard to control. Really something like sleep. Whereas with Go, because you say, oh, Windows 3, here's what's Windows.
Iron Brew? Oh my word, are you Scottish or what's going on here?
Stuck out to me.
That's a bold shout.
It's quite like that.
First sip. No, sorry, she won't do stuff like that. Righty then, I think everyone's in. Sorry, yes, should we start the next talk then? Yes, you can hear me natter on. So my talk's going to be on serverless architecture. I, as you know, work at Cloud Call and primarily have been developing our instant messaging and SMS features, and they're heavily powered by serverless. So I'm going to go into today what we've learned in architecting these solutions and also on how to, most importantly, optimize them. So first we need to briefly discuss what this technology actually is. So the name's serverless. If you're penniless, what do you have? No pennies, right? So do we no longer have this lovely little Dell R720? Well, let's find out. We sort of do, but we sort of don't. We don't need to now buy or rent our own hardware because all of that is just dealt for us. But serverless implies instead the following: that we're going to be billed for only what we use, that it's going to be scaled on demand, it's going to be load balanced automatically or automagically, and we don't have to do any maintenance. So let's break this statement down. Build for only what you use. So if you have a CRUD API, maybe it's to update your user's settings. That might be currently hosted on a DigitalOcean VPS, and it's constantly spinning away and listening for requests. Now with serverless, we're only billed per execution of the application. So for example, if someone isn't actually using your API, then it doesn't need to be billed for. Yes, where was I? Oh, it distracts me, sorry. Completely lost my place. So yeah, in all, we don't need to waste money basically when we're not using our API, because people go to sleep, people don't use your app, whatever. That's the long and short of it. Scaled on demand. Normally with VPSs or virtual machines, they respond to the CPU and RAM usage of your machine before you scale up to a new instance. But with Lambda and serverless technology, you scale per concurrent execution. So it means, in the example of your user settings API, if you receive a request into that API and then receive another request at the same time, we will just scale to another instance. So it's really easy to scale and we don't have to worry about it, most importantly. Now connected with that is load balancing. Normally you'd need to put a load balancer in front of your service to then distribute the load to your machines that you have behind it. But with Lambda and this concurrent execution scaling model, we don't need to worry about that at all. No maintenance. Now again, if you rent your own hardware, then doubtless you will have had to perhaps upgrade your operating system, maybe upgrade the packages on that machine. Maybe even if you rent hardware, they've maybe said we're going to have downtime for these periods of time. Now with the scale that we deal with the cloud providers like AWS and GCP and Azure, we don't need to worry about any of that maintenance because it's all done by the cloud provider themselves. So it's a huge cost saving there as well. Now if you're hearing this for the first time, you might be a bit skeptical. It sort of sounds too good to be true, right? Well, what's the catch? Well, there are a few cons, obviously, and we're going to go through those in the talk. But really, serverless is a truly groundbreaking technology that's shaping the future of technical architecture and also the current architecture as well. So it's a really important technology and concept to learn. So many different cloud providers offer a serverless or function as a service type offering. So you've got Azure with the creatively named functions. Microsoft took about 3 seconds thinking that one. Google with Google Cloud Functions, and then most importantly AWS with Lambda. Now I say most importantly because that's the platform I'm going to be talking about mainly in this talk. Simply being the runtimes that it has on offer far outdo the other two. The price is a lot cheaper and it runs a lot faster. So although the other two platforms are admirable, AWS Lambda just kicks their ass basically by a long margin. There's no real contest there, so I'd recommend using Lambda and AWS. So what is Lambda under the hood then? Well, very simply, it's just a Docker container. It's not really very complicated. It's just a Docker container on a service that AWS also offer called ECS, which is the Elastic Container Service. So they obviously have a few different serverless bits to this, but all in all, it's just a Docker container. Very simple. And it's important to remember this because to obviously go about optimizing, we need to think about what it actually is internally. But how else does it all work? Well, these rules are going to apply mostly to all serverless platforms, but as I say, we're going to be mostly talking about Lambda in this talk. So if a Lambda throws a new error, by just a standard JavaScript error, so you do throw new error at the top level. This is the behavior you will see where Lambda will try it again, and it will try it a third time. Now this is really great. It does this behavior silently, unfortunately, so it's very, very bad for traceability, but it is a very, very handy feature. If I'm honest, I've never ever seen a Lambda fail like this in this behavior, but it's a very, very important functionality to take hold of. You can use things like dead letter queues with SQS and improve the traceability there, but generally speaking, this is the behavior you'll see if you just host a standard Lambda. Lambdas also have a maximum execution time of 15 minutes. So this means that if you've got an API that goes off and downloads a big data file for 30 minutes, like we do at Cloud Call, then Lambda's not going to be the man for the job, unfortunately, on that particular task. So Lambdas also, it's important to remember that Lambdas aren't called, they are triggered. So what do we mean by that? So if you have a Express application hosted on Lambda, you might think that if you've got the URL for that, that URL correlates to a single Lambda. What it actually does is correlate to an API gateway. So this is another product that AWS offer. So when you call that URL, the URL will go to API gateway. API gateway will then choose the Lambda that you've specified in the URL, and then trigger the Lambda. And it will trigger it by bundling up a package with these two properties, context and event. And that will then go to the Lambda, which will then actually handle the request, bring it back to API gateway, and then return as a nice JSON response that we all know and love. So these two parameters, context and event, what are they? Well, context is the information about the request itself. So in the example of a HTTP API call, it would be stuff like your request body, your request headers, etc., etc. The event refers to the trigger. So in this case, it was triggered by API gateway. So I believe it contains the IP address of the API gateway, and it also contains things like the time and stuff like that. You never really need to use that event. The important one is the context. So what else is Lambda useful for? Well, probably not your Bitcoin mining operation, as we say, because Lambdas have a maximum execution time, but it can pretty much do anything else. So it can be triggered off of SQS messages or just queued messages. It can be triggered by cron jobs, S3 uploads, database changes, a whole host of things that you couldn't do with just a regular Docker container host. But most importantly, what we use it for mainly at Cloud Call, at least, is HTTP APIs. So the microservice architecture has exploded in recent years, and it's in part because of serverless, and because it allows us to think in a very, very modular fashion. If you think to your company or your personal projects, then I'm sure there's probably something in there that doesn't need to be running all the time. Maybe it's as I say, a certain thing like user settings. Maybe you don't need to keep that running all the time, and that will mean that you're able to cut costs, which is another advantage of serverless. Another advantage, obviously, is to split up that big monolith you may have. We at Cloud Call have a enormous C# API that we are slowly breaking down and modularizing into different microservices, and serverless has allowed us to do that, because one of the other advantages of it is that we can use multiple languages. So because AWS supports so many runtimes, we can have different teams developing different APIs in different languages and deploy them all at the same time, and it will be fine because of that modularization. But what isn't serverless very good for? Well, if you've got a CPU intensive task, like if you're mining Bitcoin, or if you are, I don't know, trying to calculate the nth prime, Lambda probably isn't the technology for it, because it has such constrained CPU resources and also such constrained file system resources. So because Lambda is stateless, you get 512 megabytes of temporary storage, and that's your lot. Also, if you don't have years and years to write your CloudFormation templates or Terraform templates, then it can be extremely time expensive to get all this stuff up and running, because you have to create all these different templates to configure the infrastructure, basically. Furthermore, if you have stuff that's latency critical, so if you're doing stuff like financial transactions or search or voice, then again Lambda isn't very good at that millisecond level latency stuff. So it's great for APIs which are latency critical, sure, but they're not as latency critical as if you're on the phone with someone, you can't be 700 milliseconds between each other because it will just interrupt the flow of the conversation. And I'm sure there's probably other things that you guys do at your companies that are very, very latency critical. But you have to just be mindful about when and when not to use it. Also, if you're a bit of an Edward Snowden type, then you might not want to have the vendor lock-in that comes with using serverless. It's a trade-off that most people are willing to take, including us, because it's so fantastic. But if you want to avoid that vendor lock-in, then again, you probably will have to look elsewhere, because there's no real great way to deploy your own stack of serverless tech. But let's say you do want to use serverless. How can we take an existing Express application and port it to use Lambda? Well, it's very, very simple. First of all, we use the serverless framework. Now, this is the easiest way of getting up and running with serverless. We just simply have this file at the root of our project. So we have a provider there set to AWS. We have the runtime of Node 8.10, which is the latest runtime for Node, unfortunately. Although I think they were going to upgrade that because they just end-of-lifed Node 6. And most importantly, we have this down here, which is process requests, and then the handler is pointed to handler.processRequests. So remember that little bit, because that comes important now, where we have this file, handler.js. So again, you place this at the root of your directory, and all this file does is proxy the requests that the Lambda gets given into nice HTTP requests that the Express application expects. So it allows you to very, very easily run the serverless app locally, as well as when you get onto your actual infrastructure. Now, you remember in the last slide we had handler.processRequests. Handler refers to the file name of the function that you want to trigger. And then process request is that actual function within that file. So the format is file name.function name. Very, very simple. And we have all these files as well in a boilerplate that I'm developing with Cloud Call. It's very, very work in progress at the minute, and I don't think it even compiles, but it does have this file in it. So if you want to refer to it for reference, then go ahead. So now we've done all that configuration, how do we deploy it? Serverless deploy. Very, very simple. That will allow you to have that Lambda that we specified in the first slide with the serverless.yaml, and it will just deploy it. Just like that, and your code will be available within probably about 5 seconds, something like that. So very, very easy. Now, I wouldn't recommend this deployment process for production, primarily because there's no traceability about who deployed the function. If it's just you, then it's fine, you know who did the deployment. But if you've got a big, big team, you're not going to know when they deployed, you're not going to know who deployed, and you're not going to know what they deployed either, because it's all zipped up and packaged before it's sent to Lambda. So it's more recommended that you use something like this. So this is the structure that we take at Cloud Call. So we have our CI, which in this case is Jenkins, build the image using Docker and zip it up, and ship the code then to S3, and then the S3 bucket is then pointed to Lambda itself. So it's very, very simple. This also allows us to use native packages as well, because Lambda doesn't support native packages out of the box, apart from FFmpeg, weirdly. So if you want to use any of the native packages, then you're going to need to use Docker to first build the code and before shipping it. So now in serverless, obviously, as I say, you pay by the millisecond rather than like a traditional model of paying by the hour or by the month. So you might be thinking, panic. My application isn't that well optimized. I'm going to be build out the nose for this. But let's take a look at how we can improve our performance. So first of all, the first step is to probably not use .NET. Or Java, really, for that matter. The runtimes have come along leaps and bounds, and they are improving day by day, which is why there's no real accurate figures about how fast these different runtimes perform, because they're constantly out of date. But generally speaking, .NET and Java have very, very heavy runtimes and are very, very slow to boot, and they also have just a slow performance in general on Lambda without bigger RAM allocations. So it's probably best to go for something like Python or Node. They're your two real showstopper big languages that you can use. Also, with your application, you might, in web development, if you've done web development before, you might think about reducing your dependencies and making your application faster because of that. So the principle being less stuff, faster to load, right? The same principle applies with serverless. So if you've got a load of stuff that your application has to do, like connect to a server, connect to this database, connect to that, and do all those sort of things, that's going to slow your boot times. And therefore it's going to be more time before that first request can be served by that particular Lambda instance. So try and reduce those if at all possible. For example, if you've got a CRUD API, you don't necessarily need to connect to the database because you might have some validation, which might mean the request gets denied anyway. So it's probably best to kind of defer those kind of operations until later. So the RAM scale. So Lambda has this very, very powerful scale where you can scale the RAM from 128 by default all the way up to 3008 megabytes, and they're increasing that every year basically. Now this is the quickest and easiest way you can guarantee your Lambdas to be faster. So with the memory allocation, it also silently scales your CPU. This isn't a linear curve, so it means that if you double your RAM, it doesn't necessarily mean you'll double your CPU resources. But generally speaking, more memory means it'll be faster. However, there is a sort of caveat to this. It doesn't always mean that. There are certain cases where the Lambda could be spun up on a machine that's already very, very saturated. The machine itself could be network I/O blocked, or maybe thermally throttled, or something like that, or maybe the scheduler at a kernel level isn't being as fair as it should be. Generally speaking though, this is how you should improve Lambda performance, but I would say keep your Express APIs at 128 unless you're really, really pushing the boundaries. But how can we figure out what the best bang for your buck amount of RAM to use is, if you like? Because as we increase the RAM, we also increase the cost to run our application. So we need to find that very, very delicate balance, as Mr. Thanos would say. So how can we do that? Well, we can test it. At the end of every execution of a Lambda, you'll get a report like this in CloudWatch. So in this case, you can see the Lambda is executed for 306 milliseconds. You can see it used 77 megabytes of RAM. It's not coming close to where we would say we need to increase that, but if that was, say, 700 milliseconds response time, and it was more like 110 megabytes of RAM, then that might be a candidate where we'd slip it up slightly and just see what, again, the response times were, and see if they came down significantly. Again, we're just trying to look for a happy medium, really, where we're not absolutely maxing out our RAM usage, and we're also not absolutely maxing out our response times as well. So the next thing also you can do is load test your Lambda. If you know you're going to be dealing with certain levels of traffic, like maybe if you're an e-commerce website, testing around Black Friday level traffic, you can do this with tools like serverless artillery. Now, load testing could be a talk within itself, obviously, but it's good to use these kind of metrics. We at Cloud Call, for example, have our SMS webhooks on Lambda, and we found that at a certain point, which was about 1,000 requests per second, they actually started to fall down very, very heavily because of the amount of connections we were creating to RabbitMQ. And that became a target now for our performance optimization. We don't have that scale yet, but it's important to bear in mind what kind of load and throughput you can actually handle on your application. So also, you've got to consider the task that your Lambda is doing. If you're doing something like image transcoding, then probably Node isn't going to be the best language to use. Something like Golang or something like Python would be far more suited to that sort of task. So it's important to think about that. In this test, it was where an application was required to go and get a 50 kilobyte image from S3, parse it, and also then update DynamoDB. And you can see here how much faster, it was up to 40% faster Golang was than the Node.js equivalent. So again, just consider what language and what kind of task you're actually performing. So also VPCs. VPCs are a very interesting and very, very great product, but also very, very annoying for Lambdas. So VPCs are virtual private clouds. They're again another AWS product which allow you to use your Lambdas or internal AWS services with your self-hosted database or your self-hosted RabbitMQ instance or something like that, and put them on the internal network. But they do have a very, very high cost when booting up a Lambda for the first time. up to 10 seconds in fact, which is very, very detrimental to performance for an end user if they're waiting 10 seconds for an API response. So just be skeptical and think about when you need to actually use a VPC. They are re-architecting the VPC architecture to make it a lot faster, which we haven't got time to go into, but you should still generally follow this kind of flow diagram when it comes to actually deciding whether to use a VPC or not. So cold starts are a thing I've mentioned quite a lot during this talk, and they gained a lot of notoriety when AWS first launched with Lambda, because Lambda froze a function after 5 minutes of inactivity, but they've slowly increased that limit now, so actually you can have a function not be called for 45 minutes and it still be active and alive for at least one instance. So it's not as big a deal as it used to be, but it still does have a negative performance on your application. As we can see here, you know, the warm call, if you like, so after it had booted for the first time, is considerably faster, obviously, than that initial boot. But you would receive these kind of scaling issues if you were using ECS or VMs anyway, so it's just about where you put that kind of scaling cost, if you like. We can prevent these measures by doing things like warming up lambdas. You might have heard of these systems whereby you ping a lambda and it simply just boots up. Because of this concurrent execution model though, that won't work unless you actually send a multitude of requests all at once. I wouldn't recommend doing this kind of thing unless you really, really have to, because it sort of breaks the ethos of serverless and how you don't have to worry about it scaling. But if you're a company like Just Eat, for example, you know you're going to be getting traffic around about 12 and around about 6. So you can gear up those periods of time by firing at about 4:58, let's say, a bunch of traffic at your Lambda and be geared up then, ready for that initial flood of dinner orders. So although, as I say, I wouldn't recommend it, if you need to do it, because customer experience trumps all. So now that we've learned how we can optimize lambdas, let's put this into practice now. And we've got a 3-step process, which is measure, optimize, and then we monitor. And the acronym for that is just remember MUM. So yeah, you can remember that acronym pretty easily. So first step is to measure what your performance is. Now this is really the stage where we're trying to look at where our app is currently. How well is it performing, or how isn't it performing? The important stage here is to just try and measure any improvements that we do make going forward, rather than actually making any improvements itself. So you can do this with tools like Bees with Machine Guns. That's a similar one to Serverless Artillery. It's kind of a load testing tool. So yeah, you can first of all measure where your app is currently, and then we can track whether we actually make any improvements with these optimizations. The next step is to actually do the optimizations. So how can we do that? Well, as we've discussed, reducing startup dependencies, scaling your memory and therefore your CPU, not using VPCs unless you really have to, pooling DB connections as well. I've not had time to discuss that, but by pooling DB connections and other connections actually, in fact, to maybe RabbitMQ or something like that, will allow your Lambda to start up and serve requests just that little bit extra fast. Caching as well is another thing. If you have a configuration, like we store our configuration in Amazon Secret Manager, instead of the Lambda going and getting that every single time we get a call to that API, we instead cache that config for subsequent requests. So you can do things like that as well that can help improve your performance. Upgrading the runtime as well. .NET Core 1.0 and .NET Core 2.0, .NET Core 2.0 is about 60% faster than 1.0. So it's always important to stay on the latest and greatest runtime that you've got for that language that you're using. And also basic things like Node-M for production. A lot of people still don't do this, where Express, if you use Node-M for production when you compile your code, you can see up to 30% performance increases on how much you serve requests. So it sounds silly, but doing all these little tiny things can add up to big changes. So now that all your optimizations are done, you need to monitor how well your app is performing, and you can be like Morgan Freeman in Batman and monitor everyone with their cell phones, however that works. So you can do this by maybe using CloudWatch again, like we did before, or you can also use Dashboard as well, which is a tool built on top of CloudWatch and provides analytics based off of it. But really, if you want to get more advanced, you want to use the king of the kings, really, which is New Relic. Now, New Relic is an application performance monitoring software, and it's so simple to implement. It's just literally one line of code, and after that, it will track each individual function and how long that function took without you having to really do anything. So it's a really handy tool. It's quite expensive, but if you've got a service that is receiving a lot of traffic, it's probably going to be worth it. If you're looking for a bit of a cheaper option to this, you can implement your own sort of solution by using Graphite with StatsD. That again is really simple to implement, and you can track things like the number of calls to an API and the amount of time that API took. So what have we learned then? So we've learned the pros and cons of serverless. We've discussed when and when not to use serverless technology. We've also figured out how to convert an application from just a standalone to a serverless stack, and primarily we've learned how to optimize them. So some very basic steps really, but I hope you found that interesting, and thank you. And if you've got any questions, then please tell me. And that's a picture of me when I was about 5. There you are. Any questions? Yes, go.
So you mentioned New Relic. Have you come across something called Datadog? Because I think we started to experiment with that one. And we used to use obviously App Insights for Azure and New Relic on the other side of things. But Datadog seems to be the one that, I don't know, seems like the phrase or the thing that people are looking at the moment.
Yeah, we did consider New Relic, Datadog as well. Datadog was a good tool, but I think it, for whatever reason, it just worked out more cost effective, and the level of insight you get with New Relic, I've not seen another tool that quite trumps it so far, if I'm honest. It's also a lot, I believe it's compatible with a number of more languages as well, whereas Datadog I think is limited to only a few. So yeah, I don't know the quite ins and outs of the two tools, but as far as I know, New Relic kind of trumps it on a few different fronts. Sorry, a little question.
We've seen that quite a few now the application as a service type things are now including functions in it. So, for instance, Firebase,
Netlify, yeah.
Function as a service. So that's an I think that's an interesting route where basically people who are actually providing your whole application, a smaller part of your application stack, if you like, but actually embed functions in it, so you don't have to go external to AWS or whatever. Have you also had any chance to look at open functions as a service, OpenFast?
Yeah, I have seen that. As I say,
I went to an interesting talk, Go Compare, about just over a year ago. They had the developer of OpenFast actually there.
all right.
That was quite an interesting sort of like workshop. It was a day's workshop on OpenFast.
So yeah, I have heard of OpenFast, and I've not personally used it. As I say, the ease of use of using a cloud provider is just really embraces the ethos of serverless, and means you don't have to do any of that maintenance, you don't have to do any of the scaling. Again, there's Netlify as well, as you say, and Firebase, but the advantage, as I say, with AWS is that they have such a big suite of products around it. Serverless is so much more than functions, right? Yeah. With AWS we have a number of functions that are triggered based off of SQS messages. You can't do that with traditional like Netlify or Firebase even. So doing that kind of thing is just great. We also have stuff that listens to Kinesis streams as well. That we do a lot of stuff with Firehose and all that kind of stuff for all our very high data volume applications. So as I say, AWS is like a really good tool for using serverless, because it just opens you up into a whole different host of way of using serverless rather than just this function as a service, if you like.
There was a guy at in Milton Keynes, the AWS sort of user group there again about a year ago. He was talking about Lambda. He said that his bill went down from tens of thousands to tens of pounds.
Oh yeah, I can well believe it. Yeah, I mean Amazon. I failed to mention this, but Amazon and Google and Azure and Microsoft, they built these tools for a reason. It's because they use them. It's very doubtful that we would ever reach a scale past Amazon and Google where we would be thinking actually a long-lived application would be cheaper. So serverless is always going to trump it in terms of cost. The only time you'll have to think about using a long-lived application is, as I say, where it's more CPU intensive, or if you're looking at latency critical stuff. That's really the two key areas. There's no real downsides to Lambda and serverless as a whole. It's more just what's the best tool for the job, really.
It also seems really ridiculous that to run a function you're running the whole Docker container.
Yes.
Have you obviously unikernels are probably going to come in the future where you actually have a much smaller slice of basically actually a native, like your app running in its own like thing, and basically it's the whole thing's managing that rather than actually a Docker container.
Yeah, so as I say,
It seems rather like overblown to actually have a Docker container for a single function.
yeah, well, you say that, but the environment, the advantage with Docker is that you're going to guarantee a consistent environment to what the developer originally intended. You know, Amazon can make zero assumptions about what code you want running on that function, and if you do things like unikernel, I don't know how that works.
So unikernel is basically all it is the API is the API of the language. So basically, you could have some like like Go or whatever it is. It's just basically can just do the things that it can do. It doesn't have all the other stuff around it. That basically is a whole server, if you like.
See, with this structure, with Docker, they can use any of the machines that they have, rather than having like certain machines for certain languages. And also, I don't know how that really behaves. The unikernel behaves with the CFP or CFS rather, the completely fair scheduler in the Unix kernel, because that's kind of how this works under the hood, whereby you assign certain resources to that Docker container, and then the scheduler kind of figures out how to manage the CPU at a kernel level. So that is, I believe, why I don't believe it's a full-blown Docker container, but it is a container Docker-like environment, really, for all intents and purposes. Yeah. Any other questions?
Have you ever tried Hexagon?
No, I haven't.
It's a monitoring service. So
Okay.
the service that you mentioned, Datadog, it's fantastic for error tracking, and I used this one, and it's super cool. New Relic is really amazing just to like track everything that is happening on your server. But there are two really cool services to use if we're talking especially about serverless architectures. One of them is IOPipe, and another one. So this is the one that we've been using for quite a while, and very recently we ditched it and we implemented everything with a Hexagon. Hexagon is our new monitoring system for serverless architecture. It's made purely to work with serverless architectures. I highly recommend you to have a look at this one because it's
okay. I'll check that out. Yeah, great. Yeah, if anyone has any other questions, then yeah, come and see me after the talk. If not, then thank you again for coming, and yeah, we'll see you next time.
Thank you.